So I've actually been looking forward to this for a while. Not just because it's a long shooting night and after this I only have one thing to shoot, but also because it guarantees that we have a very good chance of going beyond SC into double E. Earlier on with one of the worksheets, I think it was worksheet 2.2, I introduced the idea of using parallel lines in order to solve triangle problems. We can do that, and that's one of the things that we can do, but we need to go over some of the characteristics of triangles in order to use more of the resources available to us to solve problems with them. So we've got three types of triangles that we're going to start out with. The first one is the one that we solved for in 2.2, which is an equilateral triangle. An equilateral triangle means that all three of the interior angles are the same, 60 degrees, and all three of the sides are going to be equal. Whatever one side is, that's what the other two are going to be. And remember, the interior angle sum of a triangle is going to equal 180 degrees. So if you have three angles, they're all equal. Each angle is going to be 60 degrees. Pretty straightforward. So if you follow in the forms, you'll get the proper spelling of the things. So that's an equilateral triangle. The next kind of triangle is called isosceles. An isosceles triangle only has two sides that are equal to one another. And because it only has two sides equal to one another, it only has two angles that are equal as well. Looks like a very angry triangle. But if you see, this side equals this side, this angle equals this angle up here can be whatever, and this side down here can be whatever. The key feature about an isosceles triangle is that two of the angles are going to be equal, and the third angle is going to be whatever you want. Also, the two sides are going to be equal. The third side, again, whatever you want. The third triangle is called scalene. No one knows what's going on with that one. The sides aren't equal, so you have side with one length, you have side with another length, side with another length. The angles aren't equal either. Nothing is equal. You have three different sides, you have three different angles. Scalene triangles are rough. The only thing that you know about them is that they're equal to 180 degrees when you add up all the measurements together. So when we start looking at triangle problems, we're going to start looking at problems that feature triangles that we can solve using parallel lines. So we're going to assume all of these are, that these are going to be parallel lines, except for the obvious transversals. Okay. So the question becomes, if you have a drawing like this, if you have a triangle like this, or focus on the drawing. If you have a drawing like this with a triangle like this, you know that this angle is equal to 60, but you don't know what this angle is equal. So what can you do in order to figure this out? What I'm going to do is I'm going to use the angle measurements that we know, the angle relationships that we have with parallel lines, and that's going to get me all the information that I need about this triangle. So let's see. I'm going to set these two parallel lines, and I'm going to use this transversal. So that means that 60 is going to be on the exterior side. And if I want to, I can use that's what I'll do. First thing, I'll draw this line out so it's easier to see. There we go. I'm going to use the alternate exterior line principle. So if these two are my parallel lines and this is my transversal, it's starting on this side here. This angle here is 60. If I go to the alternate side, which is the alternate exterior angle, and I go all the way down here until I hit the first angle that is exterior to the parallel lines, that means that this is going to be 60 degrees also. Now that I know that this is 60 degrees, I notice that this line and this line have an intersection at this vertex. If they have that intersection at a vertex, that means that this angle is also equal to 60 because they form vertical angles. Well, this angle is 90 degrees, this angle is 60 degrees. Anytime you have a three-sided figure or a triangle, you can only get a maximum sum of 180. So all three of these added up have to equal 180, so that means that the question mark is going to equal 30. So that's one way that we can solve it. That's one way that we can use the identities that we understand in order to solve triangle-based problems. Let's take a look at another one. This is a more advanced application, so what we are going to do is I'm going to state a rule, and then I'm going to state an observation, and then what the conclusion is based on the rule. We're going to be making deductive trails where we go from one conclusion to the next, based on what we understand of the different identities and the different vocabulary terms. So, okay. All right, so we know that that is 135, we know that this is 155. UFA, right? Okay, so what can we do? We need to find out what this question mark is. We know that the interior angle measurements have to be 180, but we really don't know that much about it because these two lines are coming in at completely different angles. What can we learn and where? So what I'm going to do is I'm going to say these are my two parallel lines, and this is an exterior angle. So because this is an exterior angle, I'm going to say that the alternate exterior angles are equal here, which are going to be 135. Again, probably not to scale, but let's just work with the numbers. If we have 135 here, then that means that I can use this line here and this line here as forming an intersection. Because it's forming an intersection and it shares a vertex, that means that this angle here, again, not to scale, is equal to 135 by virtue of being a vertical angle. All right, now I've got 155 over here. I need to find what this angle is in order to figure out what the question mark is. I know what a lot of you are saying. Well, 155 minus 180 is going to give you exactly that angle. And you'd be right. So, I put it down somewhere. All right. So 155 plus 25 equals 180. So that's 135. Now that I know that this angle is 25, this angle is 135, now I can solve for the third angle, which is this question mark. So I've got 180 minus, 160, yeah. Equals, I probably didn't need to write this out, but this angle equals 20. And that is correct. That is a correct answer. So, again, take a look at where we started and what we started with. We just had two parallel lines. We had one transversal going down at a weird angle, which is fine, they're all weird anyway. But then we had this other transversal that just came in from out of nowhere and gave us a second angle here. But because we knew that this was a triangle that had 180 degrees, and we knew how to find all the different angles with the angle identities, we were able to find what that question mark was. So, let's take a look at another problem. Now this one is definitely a little bit more of an advanced application, but I would definitely pay attention to how we solve it because it gives us a few more tips and tricks and tools on how to solve these actual problems when we face them in, I don't want to say the wild, but yeah. So we're assuming again that these two are going to be parallel. Well, isn't this a pickle? Let's see, I'll move this, put this over here. This is, yeah. So what are we going to do with this? We don't have any vertical angles, we don't have any corresponding angles, we don't even have any completed lines that we can use the rules with. But what I always tell the students that I have in algebra is just because you can't see it doesn't mean it's not there. Like whenever you have an exponent, 3ab to the second, for example, 3 times a times b to the second, just because there is an exponent there doesn't mean it isn't, that you shouldn't count it. 3 has an exponent of 1, a has an exponent of 1. So just because we don't see the lines that we need in order to complete the triangle doesn't mean that they're not there. What I'm going to do is I'm going to extend the lines here and here. Now I've got a complete transversal all the way down here with these two parallel lines. Alternate interior angles, put this at 138. 138 minus 180 is 42. Now, I've got 39, I've got 42. What's the big deal, right? Well, this little thing here is a triangle, which means that 42 plus 39 minus 180 gives us this angle. So 42 plus 39 is 70, 81. So I think it's going to be like 99, yeah. So this is going to be 99. Again, not to scale. So 39 plus 42 plus 99 should be 180. If it's not, just follow the process, if not the numbers. All right, so again, big whoop. I now know what all of the interior angle measures are of this particular triangle. Hooray, whoop-de-doo. Except, by getting that 99, I have completed the traversal, which is a full line. 99 plus whatever this angle is equal to 180. So 180 minus 99, that's probably going to be equal to 39 plus 42 plus 1. 17, yeah, it's going to be equal to 81. Equals 81. And that is our answer. So again, just because we start out with these weird shapes, with these weird ideas. One of the tools that we can use, we can extend the lines that we need to. We can extend the lines out until we have the full transversals that we need. And then we just use the angle relationships and the angle identities in order to solve the problems. Now this is, like I said, a little bit more of an advanced application, but it's definitely one that I would pay attention to and that I would study going into the third exam. So what I've got are 8 more triangle problems, and then yeah, that'll probably be good enough. All right, so we know that this is 90 degrees. We don't know if x plus 60 is 90 degrees, but the thing is we don't really need to. Because we've got 2 parallel lines and a transversal, I know that the alternate interior lines for 60 are here and here. That means that they are congruent. Well, I've got 90 degrees, I've got 60 degrees, that must mean that x equals 30. And it certainly does. So again, we're just using the identity of the triangle as having an interior angle measurement of 180, and I don't even need to know what this angle is. I mean, it turns out to be 90, but that's, you know, this ray could come out from anywhere. It could come out from any angle, anywhere. but this is equal to 90. So I get the transversal down here, and I'm going to use alternate interior angles to make sure that this equals this. Then, when I have 90 plus 60, that's 150. 180 minus 150 is 30. That's how I know that this angle equals 30. That's the example of the kind of triangle problems that we're looking to solve with our angle relationships. That's supposed to be at a point. Okay. So we know what one angle measurement is. We need to know what x, y, and z are. All right? Oofa. All right. Well, let's get the easy one out. Let's get some of the easy ones out of the way. Because these are our parallel lines, we have exterior, interior, exterior. So we're basically going to be working with alternate exterior identities and alternate exterior lines. So if this is 60 and it's exterior, the alternate exterior is going to be down here, 60. Same thing with 80. Using this transversal, 80 is going to be the alternate exterior to this angle, 80. Well, if you notice, these both form vertical lines. Vertical angles, they form vertical angles. Because they appear at an intersection, they share a vertex, but they don't share any sides. So I know that z is going to equal 60, and I know that y is going to equal 80. Now that I know that y equals 80, z equals 60, I know that I add them together, that gives me 140. So 80 plus 60 equals 140. So that means that x equals 180 minus 140, which is equal to 40. Now, there's another way to verify that x is equal to 40. The other way to verify it is to see what this angle up here is equal to. So if I've got 60 and 80, that gives me 140. If I subtract it from the supplementary angle, if I subtract it from 180, because all three of these contribute to being 180. Supplementary angles are two angles that can add up to 180. But if you've got like 3 or 4 or 5 angles that all contribute and add up to 180, and you've got all but one of the measurements, you can do that. You can use, like in this case, I've got 3 angles that add up to 180. If I know 2 of the measurements, I can get the third. The third is going to be 40. And 40, if you notice, shares a vertex with x, so that makes it vertical angle. So x equals 40. We verified it twice. All right. Next one here. So this one, if you paid attention to what I was talking about with equilateral triangles or the types of triangles that I opened the video with, seeing the 3 equal sides is a dead giveaway. You know immediately that this is an equilateral triangle. If it is an equilateral triangle, you don't need to do anything else. You don't need to know anything else. So yeah, this is the missing angle. You can do it one of 2 ways. You can add 60 and 60 and make 120 and then subtract it from 180 and get it that way. Or you can recognize that what you're looking at is an equilateral triangle because all 3 sides are equal. If all 3 sides are equal on an equilateral triangle, all angles are going to be equal. Which means that whatever the angle is, there's 3 of them, and they all have to add up to 180, which means that the interior angle measurement, without even doing any calculation, all you have to do is remember the identity and remember the characteristics of the equilateral triangle, is equal to 60. And that's the correct answer. All right. So with this one, this also gets into a triangle identity question. So, we need to know what these two angles are. We know that the two angles are equal to one another because of how they're notated. But what else do we know about this? We know that this is, based on our definitions from earlier in the video, this is going to be an isosceles triangle. So it's going to have two sides equal to one another, and the third side is going to be whatever, who cares? But the thing is that we know that these two angles are equal to one another. So what that means is, whatever the angle measurement is, I'm just going to call it x, 2x, which is x plus x, because they're the same, they're equal to one another, x plus 25 equals 180. So 2x equals 155. Yeah, 2x equals 155. So x equals 155 over 2, whatever that is. And yeah, that gives you your interior angle measurements here. It gives you the individual angle measurement on either one of these. But basically all you have to do is find one and you've got the other. So again, recognizing that it's an isosceles triangle, two of the angles are going to be the same. So the way that you solve it is you take the third angle that's going to be different, subtract it from 180, and that means that these two added together are going to equal that difference. So in this case, it's 155. So again, knowing about the types of triangles that you're dealing with, that can also speed things along as far as finding the measurement of angles. Now the question is this early trigonometry? Am I giving you way too much too early as far as trigonometry is concerned? This is not trigonometry. We are still very much in geometry. All right. Well, this one's a little bit of a kicker. So, well, what I'm looking at here, actually I don't even need to use any triangle rules for this one. I figured I was going to. I was getting ready to start doing vertical angles, and I was getting ready to do vertical angles and complementary angles and all this other stuff. I don't actually need to do that with this one because I know my angle identities as well as I do. So I take these two parallels, and I take this one as an exterior angle on the transversal. If I journey down the transversal, the next exterior angle I run into is on the same side and it's equal to 30. If you remember, consecutive external and consecutive internal angle measurements always add up to 180. So if this one's 30, that means that one is 150. And since I've got the answer key in front of me, yes it is. That is indeed what that angle measurement is. So, well done to me. I know I was supposed to use the principles of triangles and things like that in order to show how to do an angle measurement, but the one thing that I want you all to take away from any of these assignments is if there's a faster way to do it that gives you the right answer, go ahead and do that. All right, here's the next one. Oof, I went all out on this one. Wow, that was awful. need you all to use your imagination on this one. So, we are trying to find this angle here. All right then. Hoofa. So what I'm going to do, I'm going to first take a look at the parallel lines. I'm going to look at the first two parallel lines, and I'm going to see 120 right here. So 120 is going to have an alternate interior angle down here. All right. Now, what I'm going to do is I'm going to take a look at these two parallel lines with this as the transversal, and I'm going to recognize that 120 is going to be the corresponding angle for this one. Because again, I'm looking at the two parallel lines with the same transversal. This is, I'm going to dirty up my drawing here a little bit. This is the same, this is drawing my F, and they're in the same relative position. Again, probably not to scale, but this gives me 120. Well, isn't this a little embarrassing? We're going to skip this problem. I clearly was not paying attention to the numbers. I was probably drawing this out when I was really tired like I am right now. We're going to skip this one. You know what? No, we're not going to skip it. I was right. I made a mistake. So I get to draw that whole thing again. Hopefully this time the lines will be a little bit better. So what I did was I looked at the drawing that I drew instead of the drawing that I had. Which is funny because I drew both of these. So these equal this equals this. So this is 120. Okay, yes, so I'm on board now. Alternate interior angle is going to be 120 down here. This is equal to 90. Oh, okay, I see what I did. Nope, still wrong. My bad. Like I said, I'll correct the sheet when I send it to you guys. But you know what I think I was trying to do? I think I was trying to put this up to 120. Because the thing is, I don't draw to scale, but it's like I'm doing these hand drawings in preparation. I don't always draw to scale, but that doesn't mean that I'm an idiot. I'm not going to say that this angle is 120 when it's clearly not. So now that I move the angle over to what could possibly be 120, let's see if this works out a little bit differently. So I'm still going to use alternate interior angles because these are my parallel lines. This is my transversal, so alternate interior angles. 120 is here, 120 is here. Then what I'm going to do is I'm going to use the corresponding angle principle. So again, I'm going to make this a little bit confusing here. Using these two as my parallel lines with this transversal, this and this means that this angle is equal to 120. So if this is equal to 120, then this must be equal to 60 because it is a supplementary angle. That's what it was. And now that this is 60, I know that 90 plus 60 equals 150, which makes this angle 30, which is the one that we were looking for. There we go. Yeah, I'll just make a note of that in class that I put the 120 on the wrong side of the line, and I don't make this stuff. I'm not a professional worksheet maker. I just try to make stuff to keep you all engaged and teach you all something, so mistakes will happen, as I'm sure you've noticed. So yeah, there we go. Using properties of triangles, alternate interior angles, and corresponding angles, There we go. It also helped having the right angles labeled the correct label. 2 more. We've got 2 more to go. Alrighty. Well, I can see immediately how I'm going to solve this. Hopefully by now, with the number of drawings that we've done, the number of angle relationships that we've done, this should be screaming out at you too. These two form vertical lines, which are equal to 60. And this is, oh man, I did it again. That's got to be 135. There we go. So that equals 135. I'm going to do the fun way again, so I'm going to do 180 minus 135. 135 equals 5. 7, 3 was 4, so that equals 45. I'm going to take advantage of the vertical angles. I'm going to say that that's 45. And with this, I'm going to solve, that's 105, 180 minus 105, 5, 7, 75. So this equals 75 and gives us our answer. So again, we've got the triangle identity where we've got the 3 angles that add up to 180. We have the correct angle measurement on the correct side of 135 and then 45, and we just take advantage of vertical angle identities and then we solve through for the final one. Again, these are just I'm not going to say fun applications, but these are just ways that you can use the angle identities that we have. If you can put parallel lines around your shape, you can solve a lot about that shape. Triangles are the best way to do that, but there are other shapes that you can use to illustrate that principle. You can use cubes too. If you remember the magical properties of cubes, it's that all of the faces, all the edges are parallel, and every intersection is 90 degrees. So what does that mean? We've got 45, so because this is 90 degrees and this one is 45, I know that this one has to be 45. Because 45 minus 90 is also 45. And 45, 90, this is also 45. One of the things that you are going to learn in trigonometry, not to spoil anything, is that there are a handful of triangles that are going to be really, really common that you run into. 30, 60, 90 triangle, 45, 45, 90 triangles. These are going to be ones that you run into all the time in order to learn some of the trigonometric functions. But also in geometry, you remember 45, 45, 90, those are the 2 angles, that'll be an isosceles triangle because 2 of the angles are the same. But also, if you take a look here, these are 2 parallel lines on our cube, and this is a traversal. So we've got parallel lines, we've got a traversal, I've got an interior angle, I've got an alternate interior angle. That means that this is equal to 45. It could have been a little bit more complicated, but it didn't have to be. I just kind of wanted to show you that you can, as long as you have parallel lines, you can use any shape that you want to. And you can use these angle relationships in order to solve all kinds of triangle problems. So next is the review, the 2.3 review, and then finally assessment 2.3, which I know you all are going to kill.